Hello, this is Dr. Alex Vernon. This is a little training to help you with binomial probability in Excel. First of all, binomial random variables are discrete random variables. And the outcome of the variable can only come from a predetermined finite set. So it's countable, something like 0, 1, 2, 3, 4, 5, all the way up to n. Here's some examples of some different variables, some of which are discrete and some of which are continuous. Number of times you roll 7 out of 10 rolls of the dice. That is a discrete random variable, something we can count. Only takes on values from a predetermined set. Number of females who walk through a door during a 25-minute period. 0, 1, 2, 3. That's also discrete. Other variables like height of NFL defensive linemen, that's continuous. Depends on how an infinite number of measures between, say, 5, 10, and 6, 1. There are some characteristics of the binomial experiment. Most stat text have these listed. They're usually listed similarly. Independent trials, independent trials, 2 possible outcomes. Success denoted by pi in this case, sometimes denoted by p. Trials are independent, kind of like a coin flip. So I'm doing a voiceover. So binomial situations are kind of like coin flips. They can be 40-60 coin flips, 0.05, 0.95 coin flips, or 0.5, 0.5 coin flips. The probability stays the same from trial to trial. You'll notice over to the right I've got the probability mass function. That's the formula, if you will, that generates the probability for a specific value of x. Here are all the arguments. First part of this formula is actually a combination, and the rest of it is just a multiplication of some powers. I've also provided the mean and the expected value formula in that. Now, let's look at a little situation here. First of all, we always need to know what the random variable is. X is, let's say, the number of times we land on heads in, let's say, 6 coin flips. So we have 6 trials. So a success is what we're interested in counting. That's landing on heads, times we land on heads. And pi is the probability of success, and that's equal to 0.5. Put these arguments in a spreadsheet. Put n is equal to 6. Probability of success, or pi, is equal to 0.5. And we built a little model. On the left I have x, and I'm going to type in the values that x can assume. It's 0, 1, 2, 3, 4, 5, and 6. So that discrete random variable will only take on those values. Create a column here for probability of x. And we're going to build probabilities in here. You can build it a couple of ways. I'm going to operationalize this function with a insert function that Excel has. And if you look at insert function and go to statistical, you can scroll down and find binom.dist, D-I-S-T. Hit OK, and it gives me a box to put the arguments in. Number of successes goes in the first box. I'm going to go to the 0 and get that. Trials, go up to the 6. Put dollar signs around this to make it an absolute reference. I'm going to tab down to the probability of success. It is 0.5. I'm also going to put dollar signs around that value to make it an absolute reference. Where it says cumulative, that's a logical operator. I'm going to put in false because that gives us the probability mass function. Probability of exactly 0 in the case right here. I'm going to go ahead and reformat just to show 4 decimals and copy this formula throughout the field. So I have probability estimates. If you'll note, the sum of all the probabilities should be equal to 1. So if I sum those up, I should get 1. And, in fact, here's the 1. We've got 1. So it looks like everything is okay. I'm also going to create a cumulative probability table. I'm going to use exactly the same function. I'm going to go in, just like I did before, and insert functions. Now I'll go to most recently used, because that's my most recently used, and there it sits, binomial dist, okay, number of successes, I'm going to get to 0, and then number of trials, $signs, probability of success with $signs, so I have absolute references for copying. And then in the cumulative box, I'm going to put true, because I do want a cumulative probability distribution. I'll go ahead and reformat to 4 decimal places, just like we did before. Copy everything through, and there they are. And you'll note 0.0156, that's the probability of less than or equal to 0, and less than or equal to 1 is the probability of 0 plus the probability of 1, and that's 0.194. And as you go down, all of those cumulative probabilities make sense. So, hope this was helpful, and good luck.